Hey everyone, my name is Magnus, and in this video I'm going to show you how I made the very first phase of my automatic changeover system, which is specially designed to control and regulate the switching process of different power sources, which can either be in the national green line or from any minute generator. I basically in this design made use of common electronics components which one can lay hands on, and more after found easy to systemize. As you can see, the body casing was actually sourced from a medium-sized Patres bus, which evenly gives it an easy and low-cost packaging criteria. Before I go further in explaining the working principle of my system, it will be important to subscribe to my channel and click the bell icon in order to get notified in my upcoming update on innovations and design like this, and that of which I teach students within and beyond, which also aid them in building theirs. Here we are in my mini development center, where I carry out my personal research, practicals and justifications of science theories. The automatic changeover system have been already developed and working efficiently as designed. I'm about losing it for you to see the interior composition of the system. You can see at least about 2 transformers and some relays. I then plug in the load line into power, and the resulting voltage is surfaced in my analog meter. The voltage is not full with respect to the reference voltage in my area, about to be precise in Nigeria, which is 220 volt AC. Now let's consider the basic circuit diagram that I developed in order to achieve the desired functionality I wanted, which include automatic changeover switching and switching off the generator once the grid line is instantly powered on. I achieved these features using 3 relays. The 2 black relays are for the load life and neutral switching, while the small relay is to off the generator. All the 3 relays are rated 12 volts, and that is why my power transformers ratings were 12 volt AC output on the secondary unit. Due to the mutual inductance principle of a transformer, I use a 12 volt linear regulator for a constant voltage output. Looking critically into the circuit diagram, the major circuitry was found to be of the AC to DC converter, which I use its output to turn on the switching relays. The working principle of this converter will be override because I've made a special video on it on my YouTube page. You can take a look for better understanding later. I made use of 3 transformers which also need 3 rectifier circuits. Converter A and B are used to switch the 3 relays simultaneously, and that is why I have them connected to the same AC source. Converter C is only connected to the generator just to power the bulb indicator, although you can just achieve that using only a resistor, a diode and a LED in these configurations. The relay neutral condition or off state is found to have the rotating probe connected to probe A constantly. In our circuit, the rotating probe is our load terminal, while probe A is our gen and probe B is our grid. This is just for the 2 black relays. The diode in all relays are used as transient protector. The working process is simple and easy to follow now. At neutral condition, the load is directly connected to the gen unit, and that is why the LED on the gen axis lightened up when I connected the load to power. Once the generator is running, its input on the 2 relay is outputted on the load. But once the grid line is powered on instantly, the converter will send 12 volt signal to the relays and change the load swing from unit A, which is the gen, down to unit B, the grid line. That implies that the incoming grid source will not be connected to the load yet. Rather, it will be connected to the 2 transformers in parallel and unit B grid line probe of the 2 relays. The principle of the switching off the gen follows the initial process, but you need to know that when you are switching off a generator, you are directly joining the 2 probe on the generator switch, while when you are switching on your generator, you are directly opening the 2 switch probe. In order to accomplish automatic switch off and on of a generator, we connect one terminal of the gen switch to the moving terminal of the 3rd relay, that is relay C, and the other to the unit B of relay C. This implies that at neutral condition, the generator is already switched on because the 2 switch probes are not connected, But once the relay is activated by the grid light, the two probe touches and short the gen, thereby instantly offing the generator. This whole process can be crafty, but if you can gradually follow the circuit, you'll be able to make yours as I did during the process. I installed it in my workspace and happily my circuit worked. The system was packaged with a sticker, but with its use for long, the sticker got old, but the system is still working as designed. Finally, I have the system dismantled in order to innovate its functionality by adding more sophisticated features like timer circuit that will aid the delay switching for such rotation and flickering of some power source like the generators. An alarm to inform the owner or its user that the grid line is on at the moment, which also will be time modulated. You can as well tell me some of the features you may like me to add. Just put it down in the comment section below. I will be glad to read them. Hope this video was of help to you. Thumbs up if you liked it. And also, as a student, I'm bound to develop more systems like this with the information I get daily. And soon, I will be posting the modified system of the automatic changeover, my water air generator, my music-based laser security system. Just subscribe to my channel in order to get notified once the system is ready. You can check us on our Facebook page at Magnum Blaze Concept. Thanks to you all. I hope to see you on the next edition. Do have a blissful day.